about Hess Law. Let me ask you first, have you ever taken different path to reach the same place? Or let's say, you want to go to the top of the hill. It's either you walk straight up to the hill or take a winding road that gradually goes up. No matter which way you choose, your total height gain is the same. In chemistry, energy works at the same way. His law states that the total enthalpy change of a reaction is the same, no matter how many steps it takes to complete the reaction. This means that if the reaction doesn't happen in a single step, we can break it into smaller steps and calculate the total heat by adding up the enthalpy changes of each step. So why is Hess law important? Hess law is important because there are reactions that is hard to measure directly. Instead of experimenting dangerous and complicated reaction, we can use Hess law to measure the energy changes. It also saves time and resources. Chemists don't need to run every experiment if they can calculate their energy using the known reaction. It also helps predict the reaction behavior. Knowing how much energy is absorbed and released can help in designing better chemical processes. And it also applies to real-world problems.
So, how does Hess law work? To understand Hess law, we need to know the two important ideas. First, enthalpy is a state function. State function means that enthalpy depends on the starting and ending points, not how the reaction happens. For example, if you travel from city A to city B, the total distance is the same, whether you take the direct flight or the multiple connecting flights. In chemistry, this means that if the reaction happens in steps, the total enthalpy change is the same as if it happened in one step. Second, breaking the reactions into steps. Many chemical reactions don't happen in a single step. We can use Hess law to find the total enthalpy change by adding or subtracting the enthalpy changes of known reactions.
Problem solving using Hess law. Step 1. Identify individual reaction and their enthalpy change or delta H. Step 2. Equations reverse or multiply coefficients to match the target reaction. Step 3. Up all the delta H values to find the total enthalpy change. Let's break down how to use Hess law to find the total enthalpy change for the reaction A goes to C using the given reactions. Find the enthalpy change for the reaction A goes to C. To understand Hess law states that the total enthalpy change for the reaction is the same regardless for the number of steps. This means we can add the enthalpy change of the individual reactions to find the overall enthalpy change. By applying Hess law, we start with A goes to B, where the delta H is equal to negative 100 kJ. This means 100 kJ of energy is released as A transforms into B. Then, consider B goes to C, where the delta H is equal to positive 50 kJ. This means 50 kJ of energy is absorbed as B transformed into C. For calculating total enthalpy change is equals to negative 50 kilojoules indicates that the overall reaction A goes to C is exothermic, meaning it released 50 kilojoules of energy.
Want to find the enthalpy change for this reaction? Carbon solid plus oxygen gas is to carbon monoxide gas. But we are given these two reactions. Carbon solid plus oxygen gas is to carbon dioxide gas with an enthalpy change of negative 393.5 kilojoules per moles, and carbon monoxide gas plus half an oxygen gas molecule is to carbon dioxide gas with an enthalpy change of negative 283 kilojoules per moles. To solve this, we need to manipulate these reactions to match the one we want. Since we need carbon monoxide as a product, we reverse the second reaction. Reversing the reaction also changes the sign of the enthalpy change. So the second reaction becomes carbon dioxide gas is to carbon monoxide gas plus half an oxygen gas molecule. The enthalpy change for this reversed reaction is now positive 283 kilojoules per mole. After manipulating the reactions, we need to add the two reactions. Carbon solid plus oxygen gas is to carbon dioxide gas with an enthalpy change of negative 393.5 kilojoules per mole. And carbon dioxide is to carbon monoxide gas plus half an oxygen gas molecule with an enthalpy change of positive 283 kilojoules per mole. When we add them, carbon dioxide gas cancels out because it's on the both sides. The final reaction we get is carbon solid plus oxygen gas is to carbon monoxide gas. After that, we add up the enthalpy changes. Negative 393.5 plus positive 283 gives us negative 110.5 kilojoules per mole. The final answer of the enthalpy change for the reaction is carbon solid plus oxygen gas is to carbon monoxide gas is negative 110.5 kilojoules per mole. So that's it! We've used Hess Law to find the enthalpy change for a reaction. Here's a quick recap. First, we broke down the reaction into smaller steps. Then we reverse reactions and adjusted the sign of enthalpy change when needed. And finally, we added everything up to the total enthalpy change. It's like solving a heat puzzle.
Now, it's my turn to solve. First thing we do, we will find if the reaction is in the right place. You see here that the second reaction produced 2 moles of NH3. We need to revise it to match the reactants to our target equation. Take note, whenever we revising the reaction, we also change the sign of change sheet negative to positive. When the reaction is in the right place, we will start to manipulating this reaction so that we will add them together and they match to our target equation. Now, we're going to cancel out elements that is not needed. Now we get our target equation and its change sheet. We have negative 1628.2 kJ.
Calculating enthalpy changes. Hess Law allows us to calculate the enthalpy change of a reaction that is difficult or impossible to measure directly. For example, the enthalpy change for the combustion of methane CH4 can be calculated by combining the enthalpy change of known reactions such as formation of carbon dioxide CO2 and water H2O. Predicting reaction feasibility. By knowing the enthalpy change of a reaction, we can predict whether a reaction is likely to occur spontaneously or not. Reactions with negative enthalpy change are exothermic and tend to be spontaneous, while reactions with a positive enthalpy change are endothermic and tend to be non-spontaneous.
Hess Law is the fundamental principle of thermochemistry. It is used to calculate the enthalpy change of reaction by summing the enthalpy change of individual parts. This has numerous practical applications in various places, such as food chemistry, Calorimetry is just the process of measuring heat change. It is used to determine the energy content for food. Hess Law play a role in this calculation, particularly in understanding the combustion reaction involved in breaking down food molecules. To add more, nutritional scientists use this information to determine the caloric value of food, which is essential for dietary planning and understanding metabolism.
Hess law shows that change of energy is independent of its pathway. That's why same energy is released while burning food.
Application of Hess laws in the food industry. So, many nutritionists and food scientists study the amount of energy in the form of calories that is liberated by a certain food type. So, the Hess law is applied there to understand how much of the calories is released when a certain quantity of the food gets consumed. So basically they're studying the biochemical and the metabolisms in the human system.
Hess Law is a powerful tool in chemistry that allows us to solve energy problems easily. Hess Law plays a major role in understanding how much energy is released or absorbed in reaction and helping industries create more efficient chemical processes. By learning Hess Law, we gain the ability to predict and control chemical reactions, making science more useful in everyday life. So guys, hopefully you learned something in our video. Thanks for watching. Bye!